So today we're starting a new unit called polar coordinates. So polar coordinates is something that's completely new that you guys have not seen before. So usually when we're talking about coordinates, we're talking about rectangular coordinates. Now rectangular coordinates are what we're used to, x, comma, y. Okay, now what we're doing now is we're changing into polar coordinates. So polar coordinates is given as r comma theta. So instead of x comma y, we now have r comma theta, where r represents the distance from the origin and theta represents the direction or angle of the point in respect to the positive x-axis. Okay, the fixed point in the center, we usually called that, if this was x, y, we usually called that the origin. Now we're calling it the pole. So if I say how far away is the point from the pole, I'm asking about how far away is it from the origin. Okay, the polar axis is the horizontal ray directed towards the right from the pole, formerly known as the positive x-axis. Okay, so we call this right here the polar axis, this guy here, and right at the center, that's the pole. So the first thing we're going to talk about is graphing polar coordinates. So it's important that we always graph our angle first. Okay, both r and theta can both be positive or negative, so you need to pay attention to that. If r is negative, then that means it goes in the opposite direction of the terminal angle. Okay, so if r is negative, we're going the opposite direction. So instead of going towards the angle, we're going to go away from the angle. Okay, if theta is negative, then that means we go the opposite direction around the circle, right? So if theta is positive, we always move in this direction. If theta is negative, then we move in the downwards direction. So our first example here. So we've got 4, 0 degrees. So 0 degrees is here, and we're going to move -4 units away from 0 degrees. So instead of going 4 units towards 0 degrees, we're going to go 4 units away. Well, the opposite direction of 0 is 180 degrees. So we're going to go 4 units. Pay attention that this goes by halves. So half, 1, 1 1/2, 2, 2 1/2, 3, 3 1/2, 4. So that is point N. We went 4 units away, the opposite direction from 0 degrees. Okay, number 2, 2, 3 pi over 2. Well, 3 pi over 2 is 270 degrees, which is down here. And we're going to move 2 circles towards 3 pi over 2. So we're going to move 2 circles. 1, 2. Okay, -2, -240. Okay, well, if we were moving 240, we would start here and we'd go all the way around and we would get to 240, which is in quadrant 3. So if I want to go -240, instead of going up 3 quadrants, I'm going to go down 3 quadrants. So I'm going to go 1, 2, 3. And 240 is a 60-degree angle, so that would be at 120. So I'm going to go -2 away from 120. So this is the same thing as 120, but I'm going to go -2 away from 120. So instead of going towards 120, I'm going to go towards 300, and I'm going to go towards 300 2 circles. So that is point U. Okay, 2, -150. Well, 150 is here in quadrant 2, and it's a 30-degree angle. So I'm going to go 2 quadrants this way at a 30-degree angle, so that's the same thing as 210. And I'm going to go 2 towards 210. Okay, lastly, we've got 2 comma 5 pi over 6. So 5 pi over 6 would be 150. So I'm going to go 2 towards 150. And that's point B. Okay, so the thing with these polar coordinates is that we can name them lots of different things, right? I could name this point B 2 comma 150. I could name it 2 comma the negative angle. Okay, we can also name this, instead of 150, if I said 330, but then used a negative r, I would be moving away from 330, which means I would get to 150. So there's lots of different ways that we can name these angles, and it would be the exact same dot. So that's kind of what we're going into in this next page here. So there's multiple ways that we can represent r comma theta, and it's the exact same point. Okay, so if a point P has polar coordinates r comma theta, then P can be represented by polar coordinates where k is any integer. Okay, so this is just giving some really crazy ways to find these. We're just going to think about it as how do we do this with just using our common sense. So point S here, I want 4 different ways, 4 different ordered pairs that I could name this point S. Okay, so I want 4 different ways. So let's first start off with the most obvious. Well, this here is at the angle 210. And it moved 2 towards 210. So it's 2 comma 210. Now that's the angle here in the positive direction. Couldn't I also name 210 in the negative direction? Okay, if I named 210 in the negative direction, then that would be negative 150. If you don't know how to do that, you could do 360 minus 210, and that gives you 150, and then we want the negative direction, okay? Or just know your unit circle. So we went 210, and then the negative angle would give us 150, right? Because this is a whole circle if we look here. Now we could also name it with negative r's. So if it's a negative r, remember we're moving in the opposite direction. So instead of going 2 towards S, we want to know, well, what if we went towards the other direction, right? So if we went this way, then that would mean we're at angle 30. So if we're at 30 degrees and we want to go to the other direction, that's what negative 2 means. Now I'm back at S. Well, once again, that's only naming 30 as a positive angle. So now let's name 30 as a negative angle. As a negative angle, 30 is 330, right? These two, if you ignore the negative, create 360 degrees, a whole circle. So if I went negative 330 and then negative 2, I'm back to S. So let's do some more examples. So we've got 2 comma pi over 4. So if we're at pi over 4, that's right here. And we went out 2 circles, let's say. Well, that's only the positive version of that. The negative version would be going this way. So we went 1, 2, 3, 4 whole quadrants. So if I named this angle in quadrant 4, that would be 7 pi over 4. So this would be negative 7 pi over 4. Okay, so now I've got 2 positives, 1 positive angle, 1 negative angle. So now let's switch to the negative r's. So if I switch to the negative r's, then I need to move to the opposite direction. So now I want this angle here. So that angle in the positive light would be in quadrant 3, which would be 5 pi over 4. And as a negative angle, we went 1, 2 quadrants. So that would be negative 3 pi over 4. Okay, number 9, we're starting with the negative 2. So where is 4 pi over 3? Well, 4 pi over 3 would be in quadrant 3, right? Because 4 is 1 more than 3. So how could we name this same angle here as a negative angle? Well, the same angle as a negative angle would be going 1, 2 quadrants, so that would be 2 pi over 3. So we're going to keep this being the same, and the same as a negative angle would be negative 2 pi over 3. Now we're going to change from negative 2's to positive 2's. So if I change to a positive 2, then that means I'm going to the opposite side. So now I need to know this angle. Well, if this was 4 pi over 3, then this has to be pi over 3. And then as a negative angle, all the way around 4 whole quadrants, almost double of 3 is 5. So 5 pi over 3 negative. Okay, I would like you to pause and try 8 and 10, and then unpause and see if you got the same answers as me. All right, so these are the answers that I got. I hope you paused and tried it on your own. So we've got 3 pi over 6. So as a negative angle, that would be negative 11 pi over 6. And then we moved across. So this angle is now 7 pi over 6, and the negative angle would be negative 5 pi over 6. So negative 3, negative pi over 2. So this time, instead of starting with a positive angle, we're starting with the negative angle. So the negative angle here is negative pi over 2. So that positive angle would be 3 pi over 2. So I left the r the same, switched from the negative angle to the positive angle. Now when I'm switching from a negative r to a positive r, I've got to go across. So now we're at positive pi over 2. And then as a negative angle, that's negative 3 pi over 2.